our adaptive immune system. I told you after presenting MHC peptide to lymphocyte T cells, TCD4 positive cells, in presence of interleukin 12 is produced by macrophage. These cells differentiate to T helper 1 and start producing interleukin 2, and interleukin 2, I told you, is important cytokines for the production and proliferation of lymphocyte T cells, and also these cells are able to produce interferon gamma, and interferon gamma affect macrophage and enhance phagocytosis and killing activity of macrophage. And also lymphocyte T helper 1 produce interferon gamma, and this interferon gamma apart from affecting macrophage, is capable of affecting lymphocyte B cells as target cells and stimulate these cells to start producing IgG1, IgG3, different type of class of IgG antibody in our immune system. And also these macrophage in innate immune system, after entering pathogens or every foreign antigen or substance, present them to lymphocyte T CD4 positive cells or T helper in presence of interleukin 4 as the other cytokines in adaptive immune system. These cells differentiate to T helper 2 cells, and they start producing more interleukin 4, and these interleukin 4 affect T helper 2 again and lead to more differentiation of T CD4 positive cells or T helper 2 cytokine. And as you know, T helper 2 is the most important subtype of lymphocyte T cells for allergic reactions and defense against elements parasites. And this T helper 2 also produce interleukin 4, and interleukin 4 affect macrophage and enhance the activity of macrophage, and plus affect lymphocyte B cells. In presence of interleukin 4, these immune cells produce IgE class of antibody. They have different class of antibody: IgA, IgE, IgG, IgD, IgM, 5 class. And lymphocyte B cells, after producing interleukin 4 and in presence of interleukin 4, differentiate to some plasma cells, are able to secrete IgE. IgE is very, very important in allergic reaction and in defense against helminths parasites. So you are seeing these specific cytokines for adaptive immune system and their role: interleukin 12 for differentiation of T helper 1, interleukin 4 for differentiation of T helper 2, and interferon gamma for producing of IgG class of antibody, and interleukin 4 for producing of IgE class of antibody. And also, after presenting antigen by MHC to lymphocyte T cells in presence of some unknown cytokines, these cells are able to produce TGF-beta, and there are controversy about this subtype of T cells. Some scientists told it's not, it's unknown this subtype, and but the other researcher or scientists told this cytokine, this T cell is able to produce TGF-beta cytokine, can be T helper 3 subtype. And also some scientists believe these cytokines can be TGF-beta, interleukin 23, and there is controversy about this subtype and their cytokines. But these T helper 3 cytokines are able to produce TGF-beta, And TGF-beta affect lymphocyte B cells, stimulate these cells, and these cells start producing IgA class. And IgA class of antibody in our adaptive immune system is very, very important in defense against viral infection, bacterial infection in a mucosal membrane, for example, in respiratory tract, mucosal membrane in respiratory tract, we have many IgA antibody, and this antibody neutralize the pathogens that enter to our respiratory tract. And so the important cytokine for producing IgA is TGF-beta. And also, I told you T helper 2, after presenting antigen, is differentiated by interleukin-4 cytokines and start producing interleukin-4. Interleukin-4 affect lymphocyte B cells, and these cells produce IgE, and this IgE, as you are seeing, binds to helminth parasite that enter to our body. And after that, some innate immune cells like eosinophils, mast cells are the most important, cells for defense against illness parasites are recruited to site of infection. And the cytokine is very, very important for recruitment of these cells. And we can say is chemotaxis factor for eosinophil and mast cell is interleukin-5. Interleukin-5 is produced by T helper 2. Not only recruit mast cells and eosinophil, but also affect these cells and lead to activation of these cells have been recruited to this site, and lead to degranulation of these cells. You know, these cell, mast cell, eosinophil have many granules in their cytosol, and the granules have many antimicrobial peptides, because these helminth parasites are very large and they aren't captured by neutrophil through phagocytosis. So these cells, through some mediators, antimicrobial peptides in their granule and degranulation, delete these helminth parasites. And so interleukin-5 is another cytokine apart from interleukin-4, is produced by T helper 2 and is very, very important for recruitment and activation of eosinophil and mast cells in helminth infection. And also interleukin-5, like interleukin-4 and aligned with interleukin-4, affect lymphocyte B cells and stimulate these cells to produce IgA. And IgA, I told you, is very, very important for the defense against some pathogen enter to respiratory tract in our body. And please tell me about interleukin-5 and interleukin-4, and in your opinion, interleukin-4 and interleukin-5 follow which type of communication, which type of antagonism, synergism. Why? I told you, answer me, excuse me. I told you interleukin-4 affect lymphocyte B cells and produce IgE. Interleukin-5 affect lymphocyte B cells, okay, and produce IgA. It's synergism, antagonism, heliotropism. Through different antibodies
activate the same
Effect
cell.
on the same.
Okay, affect the same immune cells. Okay. And but apart from TGF beta, interferon gamma, IL-12, interleukin 4, interleukin 5, I told you in adaptive immune system, sometimes after entering some pathogens, these pathogens present by MHC2, CD4 positive T cells, and in presence of some cytokines like interleukin 6, TGF beta, interleukin 21, interleukin 23, these TCD4 positive cells differentiate to T helper 17. And T helper 17 produce some cytokines like interleukin 17. Interleukin 17 is very, very important in fungal infections and in extracellular bacteria infection, and lead to recruitment of neutrophils to site of infection, and also activation of neutrophils to glucocytosis, necrosis, and the other type of defense against pathogens like producing and secreting antimicrobial peptide. And also, T helper 17 is able to produce interleukin 22. And this cytokine affects epithelial cell as a physical barrier in our innate immune system. And these epithelial cells produce a lot of antimicrobial peptides, and in this way protect us against pathogens. So I told you about different type of cytokines, that they are very, very important for adaptive immune system. Interleukin 12 for differentiation of T helper 1, interleukin 4 for differentiation of T helper 2, TGF beta for differentiation of T helper 3, and TGF beta, interleukin 6, interleukin 21, interleukin 23 are very important for differentiation of T helper 17, and interleukin 17 for recruitment of neutrophil, interleukin 22 for producing and secreting antimicrobial peptides. And these cytokines are very important in adaptive immune system. They are produced by adaptive immune cells. And also some of pathogens, some of peptides are present in TCD4 positive T cells, and in presence of TGF beta and interleukin 10. TGF beta and interleukin 10, along with each other, usually act as anti-inflammatory cytokines or immunosuppressive cytokines, and they lead to differentiation lymphocyte T CD4 positive cells to T regulatory cells. And these T regulatory cells usually produce more interleukin 10 and TGF beta and suppress the effect of T helper 1 and T helper 2 and suppress immune system. And maybe you're thinking, why in our immune system lymphocyte T cell differentiate to T regulatory? What is the importance of producing and differentiation of T regulatory cells? Do you know the importance of T regulatory?
Sometimes for grafting.
Sometimes
Grafting, like for transplantation. But we give,
transplantation.
If the immune system is activated, it should be deactivated.
it prevents autoimmune diseases.
If the immune system is working, so it should be slow. So regulatory function is to.
Okay, sometimes our immune system should be stopped. Okay, and you know.
Cells. Cells stimulate the cytotoxic cells, and when these cytotoxic cells they recognize the, for example, the pathogens
Suppresses
cytotoxic cells.
cytotoxicity. Why? Why our body need to suppress that? When
Because
some pathogen enters
Because
our
the
body,
infection-
our immune system need to be activated, not suppressed.
After the
After killing the bacteria, it will suppress.
Because there
After
are more
killing the
high.
bacteria.
deal with the
Yeah.
pathogen,
Yes.
and you know.
No, but I think because there are increases in the ILCM or GF, that will stop. I think because we have more height.
Okay. I understand. Um, okay. Pay attention, please. We need T regulatory cells because after deleting pathogen, after removing pathogen, our immune system needs to be suppressed because we don't need to stimulation and immune system. We don't need response of immune system because if immune system continue their response, their activation, our immune system can lead to overactivation of our immune system, and not only pathogen, but also our normal tissues, normal cells are also damaged. So our body, our immune system to inhibit this effect usually differentiate CD4 positive cells or T helper to regulatory T regulatory cells. So T regulatory cells are type of immune cells in our body for regulation and modulation of immune response and prevent autoimmunity in our body. And so these cells need to interleukin 10 and TGF-beta for differentiation and for affecting on T helper 1 and T helper 2.
this macrophage activate T helper cells, lot of T helper cells, and it emphasizes the phagocytic effect of this macrophage. So, what is the function of cytolytic T cells? Where are they? And after the function of cytolytic cells, it should be suppressed by regulatory cells. How they come to know that the pathogen is killed?
For cytolytic T cells, you mean what kind of cytokines are important for differentiation and function of T cytotoxic T cells?
No, here just you talk about the helper T cells. They help the macrophage. So there are also helper T cells, also cytolytic T cells, memory T cells, and cytolytic T cells. The main function of the T lymphocyte is cytolytic T cells because they kill the pathogen. So where is the pathogen and where is their role? That's one question. The next question is that when the cytolytic T cell phagocyte the pathogen. Okay. So how the regulatory T cells come to know that the pathogen is killed?
How our immune cells, our T cells, recognize to differentiate to T helper 1 or T cytotoxic T cells?
No, he's asking that how the T regulatory cells we get the signal and we have to do our work now. We have to suppress the immune system. How they come to know?
The other classmate, the other guys, can you paraphrase his question?
He's
Third.
asking how does the cells know that the pathogen is dead? How do the cells know? He's just asking.
How they are sense them?
Yeah, exactly.
Okay. How these cells sense the pathogens enter to our body to exert their function? Okay. Your question is?
No, they're saying is how does the body knows know that when the pathogen is dead? How does it know that, okay, now the pathogen is dead? How do they know, like what do they send to make it stop? How do they know?
Okay, when our immune system recognizes to stop the immune response, okay? You mean this question? Okay, because whenever in our immune system, in our body, in infection site, the pathogen is removed, okay? Our immune cells, some of our immune cells start producing some immunosuppressive cytokines. Okay, we have, for example, we have two types of monocyte or macrophage in our body. One type is classical or inflammatory cytokines, and they make up more than 90% of monocytes in our or macrophage in our body. And these monocytes or macrophage are able to produce a lot of inflammatory cytokines like or stimulatory cytokines like interleukin 1, interleukin 6, interleukin 12, and interferon gamma, and they recruit a lot of immune cells to fight off infection. But on the contrary, we have some monocytes, they are alternative or non-classical cytokines, and they are immunosuppressive. They produce many immunosuppressive cytokines like interleukin 10 and TGF-beta cytokines, and so they lead to differentiation of T-cell to regulator, because in this time our body need to immune suppression, need to control response of immune system. So in this time, with presence of interleukin, in presence of interleukin 10 and TGF-beta, our immune system recognize to differentiate to immunosuppressive some type of T-cell like T regulator cells. Okay? And so far, we've learned cytokines behave in a good way. Okay? I told you when some pathogens or foreign substances enter to our body, our immune system starts producing some inflammatory cytokines to alert the other immune cells because of presence foreign substance in our body to be recruited and make a response against the pathogen. And maybe you've heard this proverb saying a good example is the best sermon. You've heard about this proverb. I mentioned this proverb to say in our body, if the cytokines are produced in normal or physiological amount, not too much or not too low, these cytokines have many perks, many benefits for our body, because they alert our immune system, our body, because of presence some foreign substance and pathogen to deal with these pathogens and remove them from our body. But sometimes cytokines behave in a bad way. For example, imagine you are in a meeting, and in the meeting there is a person who is so talkative, and after a while, all the people in the meeting will be confused, exhausted, angry, and tired of this behavior, this person, because it's so talkative and it's talking about everything, is giving comments about everything, and after a while the other people really will be angry and confused. In our body, this example can be applied for our body, for cytokines. When a a huge amount of cytokines uncontrollably are produced in our body, in our immune system. So in this case, these amount of cytokines are not beneficial for our body, but also they are harmful, dangerous for our body. And in this part of class, I wanna talk about some disorders relevant to cytokine when these cytokines are produced uncontrollably. The first cytokine is TNF, tumor necrosis factor. I mentioned is an important cytokine, is innate immune system. But when this cytokine is produced in huge number, in large number, and uncontrollably, this cytokine lead to rheumatoid arthritis is not the one factor for causing this disease, but along with the other factors help to this disorder, help to make this disorder severe. And for example, in rheumatoid arthritis, in liver fibrosis, in psoriasis, most of them are autoimmune disease or disorder. In ankylosing spondylitis or AS, all of them, TNF is produced in huge number and lead to severe inflammation in the specific site of our body, and depend on the site is has experiencing chronic inflammation lead to different types of disorder. For example, if inflammation is the vertebra, so lead to ankylosing spondylitis. If the inflammation is inside of joints, our joints is rheumatoid arthritis. In our liver is liver fibrosis. And but these days, doctors use some TNF inhibitors to inhibit these cytokine function and alleviate the symptoms of these disorders. And these inhibitors are some monoclonal antibodies like infliximab, adalimumab, cetrorelizumab. They are the commercial name for TNF inhibitors, monoclonal antibodies in hospitals that doctors are using them. These antibodies bind to TNF receptor and inhibit, and as an antagonist, inhibit the effect of TNF and binding TNF to its receptor on the surface of target cells, inhibiting the TNF function. And but some TNF inhibitors, like fusion proteins like etanercept, are able to compete with TNF receptor because etanercept is a type of TNF receptor but is soluble. In spite of TNF receptor are expressed on the surface of target cells, etanercept is soluble TNF receptor, is commercially present these days, and after prescribing these soluble TNF receptors, these receptors compete with TNF receptors on the surface, on the membrane of target cells, and so inhibit binding the TNF to its specific receptor on the surface of cells and inhibit TNF function and alleviate and reduce the severity or symptoms of these disorders. And another type of cytokines is interleukin-1. And interleukin-1, when it's produced in huge number, uncontrollable, will lead to some disorders like lymphomas, autoimmune disorders like rheumatoid arthritis, neuroinflammation, and these days the drug for inhibiting interleukin-1 as interleukin-1 inhibitor is anakinra. Anakinra is a soluble interleukin-1 receptor, like etanercept for TNF, and compete with interleukin-1 receptor on the surface of target cells and inhibits binding interleukin-1 to its specific receptor and inhibit interleukin-1 function. Another cytokine is interleukin-6, like interleukin-1 and TNF-alpha as inflammatory cytokines, is important for some disorders like multiple sclerosis, atherosclerosis, diabetes, and as you are seeing, most of them are autoimmune disease. And when inflammatory cytokines like interleukin-1, interleukin-6, TNF-alpha are produced in a huge amount, so these cytokines lead to autoimmunity disorders that I listed some of them here. And also, this cytokine, apart from autoimmune disorder, is able to lead to some cancers like multiple myeloma. I told you interleukin-6 is very important for activation of B cells and differentiation of B cells to plasma cells. So this cytokine can be important for producing multiple myeloma. Is usually caused by hyperactivation of specific hormone of B cells. And also there are some inhibitors for interleukin-6, citalacimab and tocilizumab. All of them are monoclonal antibody and bind to interleukin-6 and inhibit binding interleukin-6 to its specific receptor. And another type of cytokines these days are used as drug, as therapeutic agent, are interferon. Usually there are different type of interferon these days are present commercially for treatment of many viral infection like hepatitis B, hepatitis C, and also are used as therapeutic agent for treatment of many cancers like melanoma, leukemia. And another cytokine and the final cytokine these days are used as drug is interleukin-2. I told you interleukin-2 is very, very important for proliferation of lymphocyte T cells in adaptive immune cells. These cytokines are produced by T cells and autocrine affect lymphocyte T cells. And they are two types of drug for interleukin therapy for treatment of some type of cancers, some type of cancers. And first drug is aldoslucin. Aldoslucin is a recombinant interleukin-2 and is used for renal cell carcinoma and malignant melanoma. Why we use interleukin-2 for treatment of this type of cancer? Why? Because I told you interleukin-2 is important for T cells, okay? And T cell as a part of our adaptive immune system is as a leader of our immune system, not adaptive, is as a leader of our immune system and is very, very important for deleting and killing the tumor cells. So interleukin-2 after prescribing lead to a proliferation and activation of lymphocyte T cells that have been exhausted in tumor microenvironment, and so interleukin-2 can be a drug for activation of T cells and defense against tumor cells and killing tumor cells. And another type of interleukin-2 is a recombinant protein. Interleukin-2 is conjugated with diphtheria toxin. also is another type of interleukin-2 complement as is used as a drug. And these cytokines, this drug is used for cutaneous T-cell lymphoma or CTLC as the other type of cancer among people. Let's sum up everything we've learned about cytokines as a language of our immune system. Autocrine usually I told you our immune system, different immune cells communicate with each other through three modes of communication: autocrine, paracrine, and endocrine. And I told you TNF. Please repeat with me. Please tell me about cytokines. I wanna understand you've learned this class well or no. Okay. So help me to summarize these cytokines together. And about TNF. TNF cytokines are produced by T cells and its effects
acute phase,
sickness behavior, CRP production, endothelial biosynthesis, and phagocytosis, and interleukin-1 produced by
macrophages, endothelial cells.
endothelial cells, and these cells are the most important cells for us. These cytokines can be produced by the other immune or non-immune cells with low amount, okay, low amount. And but the main source are these cells. And the effect of interleukin-1 is same as TNF alpha. And what interleukin-2 is
Regulation of T cells.
T cell is very important for T cells and produced by T cells. And what about interleukin-4? Cytokine of innate or adaptive?
Innate.
Adaptive. And is produced by which cell? T cells. Okay. T helper 2. And what about its effect?
Makes TH2 interleukin 5.
B cells, yes, and produce IgE. Okay. Interleukin 5.
Makes B cell make IgA.
Okay, activate B cells and produce plasma cells and which type of
IgA.
IgA. IgA. I told you IgA is very important for respiratory infections. And what about interleukin 6? Okay, produced by innate immune cells. And about its effect?
Growth of B cells.
Makes growth into plasma cells.
Okay, producing plasma cells. And the other effect of interleukin 6 is the same of TNF and interleukin 1. And what about interleukin 3 and interleukin 7? Most of them are hematopoietic factor, okay, are very important for producing immune cells in the bone marrow. It's very, very important. For example, interleukin 3 is produced in the bone marrow through some stromal cells, and interleukin 7 is also produced by a stromal cell in the bone marrow, but interleukin 3 is very, very important for differentiation of hematopoietic stem cells in the bone marrow to myeloid progenitors. And you know, in our body, hematopoietic stem cells one is a type of multipotent cells in our bone marrow and is able to differentiate different type of immune and non-immune cells. For example, is differentiate to erythroblast, erythrocyte, RBC, megakaryoblast, platelets, and also are able to differentiate to lymphocyte T, B, natural killer cell, macrophage, monocyte, granulocytic cells, and the other type. And interleukin-3 is very important for differentiation of hematopoietic stem cells to myeloid progenitors. The progenitors for granulocytic cells, monocyte, macrophage, mast cells, and but interleukin-7 is very important for differentiation of hematopoietic stem cells to lymphoid progenitors. Lymphoid progenitors are very important for producing lymphocyte T cells, lymphocyte B cells, natural killer cells, innate lymphoid cells. Every cells are type of lymphocytes. Okay. And what about interleukin-8? Interleukin-8 is type of chemokine. Okay, and is very important for recruitment of which immune cell? Neutrophil. Yes, thank you. And what about interleukin-10?
T regulation.
Bravo. Interleukin-10 is immunosuppressive cytokine and lead to differentiation of T regulatory cells. And what about interleukin-12?
It makes differentiation of T cell into T1.
Bravo, well done. T help interleukin-12 is very, very important for differentiation of T helper to T helper 1 and is produced by innate immune cells like macrophage, monocytes. And what about interferon alpha and beta? Very important for defense against viral infection. And what about interferon gamma? Interferon gamma is produced by
T1.
Produced by T helper 1 and its target?
B cells?
No. Interferon gamma is produced by T helper 1 but effect on macrophage, okay, and enhance the phagocytosis and antimicrobial activity of macrophage. And TGF-beta is a stimulatory or inhibitory cytokines?
Inhibitory.
Inhibitory, like interleukin-10 is very important for immunosuppressive responses and induce Treg and inhibit T helper 1 and T helper 2. And what about T helper 9? T helper 9 is a new subset of T helper, like T helper 1, T helper 2, T helper 17, T helper 3. And these T cells are regulator for hematopoietic stem cells and very important in asthma and allergic reaction. And what about interleukin-11? I told you interleukin-3 is very important in the bone marrow for differentiation of hematopoietic stem cells to myeloid progenitors. And interleukin-7 is very important for differentiation of hematopoietic stem cells to lymphoid progenitor. And interleukin-11 is very, very important for differentiation of hematopoietic stem cells to megakaryoblast for production of platelets. After chemotherapy, radiotherapy, usually doctors use these cytokines like interleukin-11, interleukin-3 to stimulate our bone marrow to produce immune cells like platelet, like myeloid cells, lymphocyte cells, because you know, as chemotherapeutic agents, our immune system is suppressed. Okay, the number of immune cells is reduced, and our immune system needs some triggers, some stimulator to produce more immune cells. And finish. Thank you for listening to me. And what about the quiz? Please answer this quiz in your paper present, and after that, tell me your paper. Give me your paper. The first quiz. Which cytokine induces production of IgA by lymphocyte B cells?
IL-5.
IL-5.
We have to
Okay,
fill the
correct.
box. We have to fill the boxes. Yes.
We have two boxes.
I said we have to like fill it.
Three questions, but no, it's not important. You answer two questions. Okay, great. And number two, how
B.
B.
they are involved in antiviral defense. That's correct. Thank you for listening to me, and it was the best class I've ever had. Thank you.
تعال تعال.